Hi guys, I'm stealing my neighbor's internet to do this. It's great. Okay, I totally get your internet struggles. All right, so here we go. Chemical bonds. This chapter is a little bit hard. It's going to be a little bit hard since we are separated, but we're going to do the best we can with what we got. Okay. So this is the notes. I probably am going to have to do it like another little video of me doing some Lewis dots for you to like truly understand this, but we'll do that. So, okay, the first lesson is kind of why things bond, and the second lesson is how they bond. All right, so the big thing here in this chapter is elements link together with other elements to form chemical bonds. Okay, and the reason they do this is because it makes them more stable. Okay, so here we go. Essential questions. How does a compound differ from its component elements? And if you watched that video that I keep telling you to watch, Hunting the Elements, you know. What does a chemical formula represent? How do Lewis dot diagrams help us predict chemical bonding? And why does it occur? All right, so a chemical compound is something that is formed from two or more elements that form a bond to become more stable, and it has a fixed composition. Okay, so sodium chloride or table salt, NaCl, that's a compound. H2O, water, that's also a compound. All right, so there we go, our new vocabulary. All right, so there are all sorts of elements around you, but most of them are actually chemically combined with other elements to form compounds. Okay, example, they made the Statue of Liberty out of copper, which is copper colored, but in the air there's oxygen and sulfur, and so those two things together, plus the copper in the Statue of Liberty, form something called copper sulfate, which is that green compound that you see when you look at the Statue of Liberty now. It's basically a form of rust. Okay? All right, so there you go. Copper plus sulfur gives you copper sulfate, which is really cool. Okay, but if you notice, copper is this beautiful color, sulfur is this yellow color and stinks terribly, and then when they combine to form a compound, you get something that's a really cool green color. Okay, so the elements in a compound, the qualities of those elements have very little to do with what the actual compound will be. Okay, so we use formulas, okay, and you can see some of them over here. For example, milk of magnesia is magnesium hydroxide. That's the chemical formula. Okay. Vinegar is called acetic acid, CH3COOH. So these chemical formulas are agreed upon through all chemists across the whole world, and it just makes things a lot easier. Okay. If you notice, it's the elemental symbol Ca for this one, calcium oxide, plus the symbol for O, okay? And it also has numbers with it. So this one doesn't have any numbers, so they're combined 1 to 1. If you go up here, sucrose, sugar, C12H22O11. So in this molecule, in one molecule of this compound, there are 12 carbons, 22 hydrogens, and 11 oxygens. Okay? All right, so this should look semi-familiar. These are the Lewis dot models, or the Bohr models actually, of the top, well, almost the top, the second two periods of the periodic table. Okay, if you notice, we start here with 1, and then 2, and then skip over to 13, 3, 4, 5, 6, 7, and 8. Okay, 8, and more specifically, a full outer shell, are two of the most stable configurations of electrons. So everybody else wants to get to 8 or a full outer shell, whichever one is easier. Okay? So back to these essential questions. How is a compound different from its component elements? They're almost unrelated. Okay? And if you remember the video, the Hunting the Elements video, the first part where they take sodium and chlorine gas and they make salt onto popcorn, you'll know what I'm talking about. Chemical formula is a shorthand that tells you the ratio of the elements in it. How do Lewis dot diagrams help predict chemical bonding? I'm going to probably make a short little video just of this to help you because it's a little complicated, but it actually shows you how there's room to fill that outer shell. Okay, so Lewis dots with the, you know, the symbol with the dots tells you how many kind of parking spots. I've kind of used that analogy. Parking spots are open to bond. Okay. And then why does chemical bonding occur? To make the elements more stable. Okay. That leaves us with the 18.1 questions 1 through 6. You may have to spend a little bit of time with your book on this one. Okay. And I'll probably be on a little later in the week with those Lewis dot things. Okay. Have a good day, guys. I miss you.